Hi there. In this video we're going to look at some binomial expansions, and this is really a pre-calc topic, but I want to review it real quickly with you because we're going to need it in a proof that we're going to be looking at in the next video. So I will give you a crash course in binomial expansions. Okay, what do I mean by a binomial expansion? Well, here's a binomial and it's being raised to the nth power. How do you expand a binomial when raised to the nth power? Well, the way we're going to do that is we're going to look for some patterns. So the first binomial is being raised to the 0 power. In other words, n equals 0. I don't think anybody would disagree with me that this would just equal 1. Okay, the second one. This isn't too hard to check. If you wanted to raise x plus y to the first power, what do you get? Well, you just get 1x plus 1y. And I'm going to leave those coefficients there. Hopefully you'll see why in a minute. The second one, you can check this very quickly on your own. Perhaps you could do it in your head. You're going to get x squared, or 1x squared, plus 2xy, and I'm actually going to put 1's as exponents on those, plus y squared. Okay, the third one, x plus y cubed. Well, if you don't believe me, you can just take this guy and multiply it by x plus y one more time, and you will get x cubed plus 3x squared y to the first plus 3x to the first y squared plus y cubed. Okay, so maybe you're already starting to see some patterns develop here. Let's see if we did one more. See if you can predict what's going to happen. If you have x plus y raised to the 4th power, okay, n equals 4, well, what would be this expansion? Well, the first thing you notice is that we have 1's all alongside the left-hand part of this pyramid. So maybe my first coefficient is 1. X to the what power? Well, if you notice, this is x to the first, x squared, x cubed. It makes sense that this is x to the 4th. Same thing down this line right here, the right-hand side of the triangle. Most likely over here we're going to have a coefficient of 1, and this is going to be y to the 4th power. Okay, now the question is, what about these other coefficients in here? Where did this 3 come from? Well, if you look carefully, where did this 2 come from? Look at the two numbers above it. 1 plus 1 equals 2. Look where this 3 came from. 1 plus 2 equals 3. So it makes sense that I might be able to take 1 plus 3, and that might equal my coefficient for this guy. 3 plus 3 is 6, and 3 plus 1 is 4. Okay, well, what about the variables themselves? What are they doing? Well, let's go back to the previous line. Let's look at x cubed, then we have an x squared, then we have an x to the first, and there's really an x to the 0 right here. So it makes sense that this row might go x to the 4th, x cubed, x squared, x to the first, and there's really an x to the 0 right here. What about our y's? Well, our y variable is going to be doing the same thing except in the reverse order. We really have a y to the 0 here. Here's y to the first, y squared, y cubed. And then we just need to throw some addition signs in here, and we're done. We've expanded x plus y raised to the 4th very quickly without doing any algebra at all, just simply sticking to this pattern. Okay, well, what if we wanted to find x plus y to the 10th? Okay, well, using these patterns, you would probably have to go through x plus y to the 5th, the 6th, the 7th until you got to the 10th. That can be a little bit cumbersome. So we want a quicker way to find x plus y to the 10th using the same patterns, but maybe finding a little bit easier way to find these coefficients. Well, in walks our friend the combination. Okay, what do I mean by that? Well, I'm not going to give you a lesson in combinations right now, but I will briefly explain what I mean by it. What do I mean by combination? A combination can be written as follows. Okay, some parentheses, and I have a 1 up top, a 0 in the denominator, and we read this 1, choose 0. Another way to think of this is if you have a bag of marbles and there's only one marble in the bag, and you reach in to grab 0 of them. How many different ways can you grab 0 marbles from a bag of 1 marble? Well, there's only one way to do that. How about this guy? Turns out this combination is the combination 1, choose 1. In other words, you have a bag with only 1 marble in it. You want to reach in and grab one of those marbles. How many different ways can you do that? Well, there's just one way to do that. Okay, so what about the second row? How do we get this guy? Well, we're in the row that equals n, where n equals 2. So now I have 2 marbles in the bag, and I want to choose 0 of them. Well, there's only one way to choose 0 marbles from a bag of 2 marbles. How about this guy? This is where hopefully it'll start to make a little bit more sense. You have a bag with 2 marbles in it, but you only want to pick one of those marbles. Maybe it's a red one and a green one. How many different ways can you reach in the bag and grab one of those marbles? Well, 2. And then finally, this last one. You have a bag of 2 marbles. You want to reach in and grab 2 of them. How many different ways can you do that? There's only one way to do that. This row, real quickly. This would be 3, choose 0, which by now you'll see is 1. 3, choose 1. How many different ways can you reach in a bag of 3 marbles and only pick one of them? Well, there's 3 different ways to do that. This guy here will be 3, choose 2. And this will be 3, choose 3. So now we have a little bit more efficient way of calculating our coefficients. The only problem is you need to know how to calculate a combination, and for this proof we don't need to know that. We just need to know that there are quick ways to get these coefficients. Okay, so real quickly, if I wanted to expand x plus y to the 10th, how would I get that? Well, the first coefficient is going to be 10, choose 0. X to the what power? X to the 10th, y to the 0. Plus, what's my next one going to be? It's going to be 10, choose 1, which we know is 10. X to the 9th power. Remember that the powers just decrease by 1 and the y's increase by 1. Plus, I'll just do a couple more of these here. 10, choose 2. X to the 8th power, y squared. And this is going to keep going until we get to 10, choose 10, x to the 0, y to the 10th. And you can come back and simplify this, calculate all these different combinations, simplify, and you're done. Okay, that is a crash course in a binomial expansion, which we will need in the proof in our next video. We'll see you there.